Unacademy, let us crack GATE ME, let us crack GATE Civil. Unacademy is congratulating GATE 2023 top rankers. Crack GATE XE with top educators. Engineering mathematics, fluid mechanics, solid mechanics, thermodynamics and general aptitude. Subscribe now. Use code KUR75. For iconic subscriptions, 15 books are home delivered within 15 days. Fluid mechanics, hydraulic machines, refrigeration and air conditioning, power plant engineering, industrial engineering, strength of material, machine design, engineering mechanics, thermodynamics, manufacturing technology, material science, heat transfer, engineering mathematics, general aptitude, GATE PYQs volume 1 and volume 2. Home delivered within 15 days. Unacademy is announcing all-star batch, one batch for all. GATE ESE 2024 batch commences from May 26th. Unacademy is announcing all-star batch, one batch for GATE ESE 2025 batch commences from May 26th. Unacademy Center for GATE. New offline batch starts from June 19th. Admissions are open. Avail existing discounts. Few seats are left. Use scanner code or call 8585 858585. For personalized career counseling and platform support, call 8585 858585. Welcome to the basic engineering series. Engineering mathematics, probability, basic concepts of probability. Consider two events E1 and E2. Probability of E1 is 1 by 2. Probability of E2 is 1 by 3. Probability of E1 intersection E2 is 1 by 5. Which of the following statement is true? Probability of E1 union E2 is 2 by 3. Probability of E1 union E2 is probability of E1 plus probability of E2 minus probability of E1 intersection E2. 1 by 2 plus 1 by 3 minus 1 by 5. That is 19 by 30. But given that it is 2 by 3, therefore it is incorrect. E1 and E2 are independent. If E1 and E2 are independent, probability of E1 intersection E2 is probability of E1 into probability of E2. They are not equal. Probability of E1 intersection E2 is not equal to probability of E1 into probability of E2. Therefore, E1 and E2 are not independent. E1 and E2 are not independent. Next, if E1 and E2 are two events in a probability space satisfying the constraints, probability of E1 equal to probability of E2, probability of E1 union E2 equal to 1, E1 and E2 are independent, then probability of E1 is since E1 probability of E1 equal to probability of E2, one plus probability of E1 whole square minus 2 into probability of E1 equal to 0. That implies P of E1 minus 1 whole square equal to 0. Therefore, probability of E1 minus 1 equal to 0, probability of E1 equal to 1. Finally, probability of E1 equal to 1. That is the correct answer. Next one. A hydraulic structure has 4 gates which operates independently. Probability of failure of each gate is 0.2. If gate 1 has failed, given that gate 1 has failed, the probability that both gates 2 and 3 will fail. Now, gate 1 has already failed. Now, gate 2 and gate 3 also fail. That means conditional probability. Gate 1 intersection gate 2 intersection gate 3 by probability of gate 1. Since all the gates are fails independently, therefore probability of failure of gate 1, because they are independent, into probability of failure of gate 2 into probability of failure of gate 3 by probability of failure of gate 1. Probability of failure of gate 1, probability of failure of gate 1 under cancellation. Probability of failure of gate 2 is 0.2, gate 3 is 0.2, final answer is 0.2 into 0.2, that is 0.04. 0.2 into 0.2, that is 0.04. A coin is tossed 3 times in succession. If the first toss produces a head, then the probability of getting exactly 2 heads in 3 tosses. A coin is tossed 3 times. If the first toss produces head, already happened. What happened? First toss produces head. What is the chance that exactly 2 heads in 3 tosses. So remaining 2 tosses could be tail tail or tail head, head tail or head head. First toss produces head. So we have to calculate the probability of getting exactly 2 heads in 3 tosses. Exactly 2 heads. These two are favorable cases. These two are favorable cases out of 4 cases. Therefore, the required probability is 2 by 4. That is nothing but 1 by 2. The required probability is 1 by 2. A fair dice is rolled twice. The probability that an odd number will follow an even number is, odd number will follow an even number means 1 by 2 into 1 by 2. Chance of getting odd number is 3 by 6. Even number is also 3 by 6. That is nothing but 1 by 4. Required probability is 1 by 4. One by 4 is the answer. Two cards are drawn at random in succession with replacement. From a well shuffled pack of 52 cards. What is probability of getting both the aces? Both are aces. First one is an ace card. Second one is also an ace card. 4c 1 by 50 to c1 into 4c 1 by 50 to c1, because the experiment is done with replacement. 4 by 52 means 1 by 13 into 1 by 13, that is 1 by 169. 1 by 169. Next one. In a game, two players X and Y toss a coin alternatively. X and Y toss a coin alternatively. Whoever gets a head first, the person wins the game, and the game is terminated. Assuming that player X starts the game, what is the probability that player X wins the game? Assuming that player X starts the game, what is the probability that player X wins the game? So game is between X and Y. X and Y are throwing a coin alternatively. First X starts the game. First X throws. If X fails to get head, then chance will come to Y. If Y fails to get head, then chance will go to X. If X fails to get head, chance will come to Y. If Y fails to get head, chance will come to X. Like that, game is continued. Our job is to calculate winning chance of player X. Winning chance of player X. First throw, X wins the game. Otherwise, first throw, X fails. Second throw, Y fails. Third throw, again X has a chance to win. First throw, X fails. Second throw, Y fails. Third throw, X fails. Fourth throw, Y fails. Fifth throw, again X has a chance to win. Now, winning chance of X. Okay, what is the chance that X gets ahead? 1 by 2. R means plus. X fails. Y fails. X wins. X fails. Y fails. X fails. Y fails. X wins. And so on. 1 by 2 of 1 plus 1 by 4 plus 1 by 4 whole square plus and so on. That is A by 1 minus R, 1 by 1 minus 1 by 4, 1 by 3 by 4, 1 by 2 into 4 by 3. That is nothing but 2 by 3. Winning chance of player X is 2 by 3. Winning chance of player X is 2 by 3. A coin is tossed 10 times. What is the probability that only first 2 tosses will yield heads? Only first tosses will yield heads. There is a condition. Only first 2 tosses will yield heads. Third toss to till 10th toss only tail. That is 1 by 2 whole power 10. 1 by 2 whole power 10 is the required probability. Assume for simplicity that n people all born in April are collected in a room. Consider the event of at least 2 people in the room being born on the same date of month. What is the smallest value of n so that the probability of this exceeds 0.8? So at least 2 people in the room born in the same date of month. Now, calculating probability of at least 2 people born in the same date of month, 1 minus probability of none of them born on same date of month. Indirect approach. That is 1 minus for first person is not born on the same date of month. That means 30 total number of cases, favorable cases are also 30. For second person, this date should not be. That's why 29 by 30. That is 1 minus 29 by 30 that is 1 by 30, which is less than 0.5. So next, let us take n equal to 3. Now the required probability, probability of at least 2 of them born on the same date of month, 1 minus probability of none of them. First person 30 by 30, second person 29 by 30, third person should not born on the remaining 2 dates, that's why 28 by 30. If you simplify this, this is also less than 0.5. For n equal to 4, calculate in the same manner. Probability is 1 minus 30 by 30, 29 by 30, 28 by 30, 27 by 30, which is also less than 0.5. Like that, if you calculate for n equal to 7, the required probability is 1 minus 30 by 30, 29 by 30, 28 by 30, 27 by 30, 26 by 30, 1, 2, 3, 4, 5, 6, 24 by 30, which is equal to 0.53, which is greater than 0.5. For n equal to 7, the required probability is greater than 7. The required probability is greater than 0.5. For n equal to 7, the required probability is greater than 0.5. Therefore, n equal to 7 is the correct answer. There are 2 containers. One containing 4 red, 3 green. Another containing 3 blue, 4 green. One ball is drawn from each. One ball is drawn from first container, another ball is drawn from second container, because he has mentioned clearly one ball is drawn from each. One is red and other one is blue. One is red and other one is blue. Twelve by 49. A coin is tossed till head appears for the first time. The probability that the required number of tosses is odd. The required number of tosses is odd. That means you have to get head either in the first toss or in the third toss or in the fifth toss, like that. Remaining trials tail. 1 by 2, R means plus. 1 by 2 into 1 by 2 into 1 by 2, R means plus. And so on. A 1 by 2 of 1 plus 1 by 4. 1 by 4 square and so on. A by 1 minus R 1 by 2 of 1 by 3 by 4 1 by 2 of 4 by 3, that is 2 by 3. The required probability is 2 by 3. Next problem. An unbiased coin is tossed 4 times in succession. The result is the following. The result of the experiment is given in the data. First time head, second time head, third time head, fourth time head. What is the probability of getting tail in if you toss again? So fifth toss tail. See here. Every trial is independent. Getting of head in previous trial and getting of tail in present trial, both are independent. One is not affecting other. Therefore, chance of getting tail in fifth toss is 1 by 2 only. Understood? Next one. Probability of E denotes probability of E. Given that P of A equal to 1, P of B equal to 1 by 2, then the values of P of A by B and P of B by A respectively. P of A by B and P of B by A respectively. Here P of A is given, P of B is given, and P of A by B and P of B by A. Suppose A and B are independent. P of A into P of B by P of B. After cancellation, you will get P of A. P of A is 1. P of B is 1 by 2. Next, if P and Q are two random events, then which of the following is true? If P and Q are independent, P intersection Q, probability of P intersection Q is 0. That is incorrect, false. Next, probability of P intersection Q greater than or equal to probability of P plus probability of Q. This is also false. Actually, probability of P intersection Q is less than or equal to probability of P. If P and Q are mutually exclusive, they must be independent. That is also false. If P and Q are mutually exclusive, then probability of P intersection Q is 0. Next, probability of P intersection Q less than or equal to probability of P. That is correct. Probability of P intersection Q less than or equal to probability of P. Next. An examination consists of two papers, paper 1 and paper 2. The probability of failing in paper 1 is 0.3. The probability of failing in paper 2 is 0.2. Given that a student has failed in P2, chance of failing in P1 is 0.6. Probability of failing in P1 is 0.3. Failing in P2 is 0.2. Given that a student has failed in P2, chance of failing in P1 is 0.6. Next, a box contains 4 white balls and 3 red balls. 4 white balls and 3 red balls. 4 white balls and 3 red balls. In a succession, 2 balls are selected randomly and removed from the box. Given that first removed is white, second removed is red. Box contains 4 white, 2 red. Two balls are randomly selected and removed from the box. First one is white and second one is red. Total 7 balls are there. From 7, 2 balls are selected. What is the chance that one is white and one is red? 8 by 21. 3 red, sorry. Here we have 3 red. Select 1 red from 3. The required probability is 4 by 7. Next one. A box contains two washers. A box contains 2 washers, 3 nuts, 4 bolts. The products are selected. One by one without replacement. without replacement, the probability of drawing 2 washers first, followed by 3 nuts and subsequently 4 bolts is. Now, two washers, 3 nuts, 4 bolts. Now, first one is washer, second one is washer, next nut, next nut, next nut, next bolt, next bolt, next bolt, next bolt. Now, select washer, 2C1 by 9C1, 1C1 by 8C1, 2C1 by 9C1, 1C1 by 8C1, 3C1 by 7C1, 2C1 by 6C1, 1C1 by 5C1, then select bolt. 100% you are going to get bolt. 4 by 4, 3 by 3, 2 by 2, 1 by 1. Simplify this. 1 by 1260. The required probability is 1 by 1260. Two fair coins are flipped. At least one of the outcomes known to be head. What is the probability that both the outcomes are heads? Two fair coins are tossed and at least one of the outcomes are to be head. See, here if two fair coins are flipped, at least one of the outcomes is known to be head. So 3 cases are favorable. 3 cases are possible total. What is the probability that both are heads? Both are heads is only one case. Therefore, correct answer is 1 by 3, because you have to toss the coins till you get one of the outcomes is head. Either tail head or head tail or head head comes, you are going to stop. Among these 3, how many are favorable? Only 1 is favorable. So 1 out of 3 is the correct answer. Next. A screening test is carried out to detect a certain disease. It is found that 12% of the positive reports and 15% of the negative reports are incorrect. Understood? A screening test is carried out to detect a certain disease. It is found that 12% of the positive reports and 15% of the negative reports are incorrect. Assuming that probability of a person getting positive report is 0.01, the probability that a person tested gets an incorrect report is Now, a screening test is carried out to detect certain disease. The person is tested. He may get positive report or negative report. Chance of getting positive report is 0.01. Negative report is 0.99. The report may be correct or incorrect. Chance of getting correct is 12% of the positive reports are incorrect. 12% are incorrect. So 88% are correct. 15% of the negative reports are incorrect. So 85% are correct. We have to calculate the probability that the report is incorrect. Here, if you follow the tree, the report is positive and it is incorrect, or the report is negative and it is incorrect. So you have to multiply like that. 0.01 into 0.12 plus 0.99 into 0.15 0012 1485 1497. 0.1497 is the required probability. Next one. Observe. Consider a company that assembles computers. The probability of a faulty assembly of any computer is P. The company therefore subjects each computer to a testing process. This testing process gives the correct result for any computer with a probability Q. What is the probability that the company the probability of computer being declared faulty? The computer being declared faulty. The computer being declared faulty. the computer being declared faulty. Now, the company assembles computers. The probability that faulty assembly of computer is P. Faulty assembly of computer is P. In the testing process, it is a faulty assembly of computer. In the testing process, if it is correct, Q, R, it is incorrectly assembled and they have given that it is found correct. So, this is total theorem of probability. Now we have to find out what is the probability that it is being declared faulty. Yeah, you have to apply only total theorem. Therefore, declared faulty means it is assembled incorrectly and the result shows correct, or it assembles correctly but the result shows incorrect. So PQ plus 1 minus P into 1 minus Q is the correct answer. Understood? Now, observe next problem. An automobile plant contracted to buy shock absorbers from suppliers X and Y. X supplies 60%, Y supplies 40% of the shock absorbers. X supplies 60% and Y supplies 40% of the shock absorbers. All the shock absorbers are subjected to a quality test. Of X shock absorbers, 96% are reliable. Of Y shock absorbers, 72% are reliable. Of Y shock absorbers, 72% are reliable. The probability that randomly chosen shock absorber found reliable is made by Y. It is a problem designed on Bayes theorem. There are two companies or two suppliers, X and Y. X supplies 60%, Y supplies 40%. Reliability is an arbitrary event. Reliability is an arbitrary event. Of X shock absorbers, 96% are reliable. Of Y shock absorbers, 72% are reliable. Now, if a shock absorber found reliable, what is the chance that it is supplied by Y? It is supplied by Y. Now, 0.40 into 0.72 by 0.60 into 0.96 plus 0.40 into 0.72. Simplify this. 0.334. Understood? 0.334. Next problem. The probability that a student knows the correct answer to a multiple choice question is 2 by 3. The student does not know the answer, then the student guesses the answer. If the guessed answer being correct is 1 by 4, given that the student has answered the question correctly, what is the conditional probability that the student knows the correct answer? Observe. Now, student knows the answer is 2/3, therefore guess the answer is 1/3. Answer correct is an arbitrary event. If the student knows the answer, it is 100% correct. If the student guesses the answer, the probability that the guessed answer being correct is 1/4. If the answer is correct, what is the chance that student knows? So 2/3 into 1 by 2/3 into 1 plus 1/3 into 1/4, 2/3 by 8 plus 1, 12/9, 3 4 ja 12. Final answer is 8/9. Next, a group consists of equal number of men and women. A group consists of equal number of men and women. 20% of the men and 50% of the women are unemployed. 20% of the men and 50% of the women are unemployed. If a person is selected at random, what is the probability that the selected person is employed? See here, he has given employed, but the data is given for unemployed. Be careful. Now, there are 50% of men and 50% of women. In that, unemployed, employed, unemployed, employed. Now, 50% of the women are unemployed, 20% of the men are unemployed. 20% of the men are unemployed, 50% of the women are unemployed. Now, the probability that the person is employed. See, men employed, women employed. See here, 0.50 into 0.80 plus 0.50 into 0.50. That is nothing but 0.4 plus 0.25. That is nothing but 0.65. The required probability is 0.65. The required probability is 0.65. Understood? Next. In a given day in the rainy season, it may rain 70% of the time. The chance that village fair will make a loss on the day is 80%. However, if it does not rain, loss is only 10%. The fair has not made any loss on the given day in the rainy season. The probability that it has not rained on the day. So it is also a problem on Bayes theorem. Rainy day and non-rainy day are mutually exclusive. Data is given in terms of rain, but data is given in terms of loss and problem is designed in terms of gain. chance of a rainy day is 70%. Non-rainy day is 30% automatically. Gain is an arbitrary event. Gain is an arbitrary event. If there is a rain, loss is 80%, therefore gain is 20%. If there is no rain, loss is only 10%, so gain is 90%. If there is a gain, what is the chance that that gain came from non-rainy day? That is 0.30 into 0.90 by 0.30 into 0.90 plus 0.70 into 0.20. Simplify this. Simplify this. 27 by 41. The required probability is 27 by 41. Understood? Thank you.